Okay, so today we're going to be talking about right triangle trig, but before we do that, we need to talk a little bit about some of the things that we're going to be dealing with, okay, after right triangle trig. So, first and foremost, what is the unit circle? Well, the unit circle is a circle with a radius of 1 unit. Okay, there's a unit figure for all shapes. So a unit circle has a radius of 1. A unit square has 4 side lengths of 1. A unit triangle has 3 side lengths of 1. So when we talk about a unit circle, or a unit square, unit triangle, the length of its major component is 1 unit, whatever that unit is. Okay? What is the equation of a circle? Well, the equation of a circle is x squared plus y squared equals r squared. Okay? Which means that the equation for the unit circle is x squared plus y squared equals 1 because the radius of the unit circle is 1. This equation, y squared, x squared plus y squared equals 1, the unit circle equation, is going to become really important later on. Okay, so, and then we'll go over more equations of circles when we get to conic sections. Okay, but we're just getting some basic definitions out of the way. All right, so when we first learned right triangle trig, we learned it in geometry as SOHCAHTOA. Okay, and that's the way a lot of the teachers teach. So, SOH right here, basically standing for sine equals the opposite side over the hypotenuse. So if your theta, which is your angle, is right here, the opposite side is the side across from the angle. And of course your hypotenuse is the side away or across from the right angle. The actual right angle symbol points at the hypotenuse. So this right here points at the hypotenuse. Okay? Now, so that's so. So, katoa, sine opposite of hypotenuse. So the second one is cosine. And cosine is adjacent over hypotenuse. And adjacent means next to. So it's the adjacent side divided by the hypotenuse. Okay? And then we learned TOA, which is tangent equals opposite over adjacent. And the opposite side, which same from sine, and the adjacent side, the same from cosine. Okay, so this is SOHCAHTOA. This is the first time we learned right triangle trig. Okay, now these are just 3 of our 6 major trig functions. Okay, so let's start with the ones that you know. Sine equals y over r, or opposite over hypotenuse. So this triangle over here, what I've done is I've taken that same triangle over there and basically thought of it as, say, this triangle here. This is the x and y axis right here. Okay? So this side is your x and this side is your y part. Okay? And then this r right here is the radius, basically if we drew a circle like this, okay, with a central angle. Okay? So this is the x part, this is the y part, and this is the radius to the edge of the circle. Okay, so that's where this triangle comes from and why we say hypotenuse is the same thing as r, or the radius. And the x part is the adjacent side, if this is your angle right here. Okay, and your opposite side is also what we consider y, when it's sitting in this standard form. Okay, so we know sine, we know cosine, and we know tangent. Okay, so I rewrote sine, cosine, and tangent, the SOHCAHTOA, in terms of also as x and r and y. Okay, so these are the 3 that we know. These equations right here are going to be very, very important. You have to have these equations memorized, what they're equal to. Okay, now let me introduce your newest members. Okay, there are 3 new trig functions that we're going to be dealing with. Okay, here we go. Cosecant. Okay, this is literally cosecant. Okay, and cosecant is nothing more than the reciprocal of sine. That's why it says 1 over sine. Okay, because if sine is sine over 1, then cosecant is 1 over sine, the reciprocal. So if sine is y over r, cosecant is r over y. If sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Okay? So I'm going to get rid of this part here. So basically what we're doing is cosecant is the reciprocal of sine. Okay? So that's one of the new ones. Well, cosine has a reciprocal too. Cosine's reciprocal is secant. And secant is the reciprocal of cosine. And again, if cosine is x over r, then secant is r over x. If cosine is a over h, adjacent over hypotenuse, secant is hypotenuse over adjacent. Okay? And then the third one is cotangent. Okay? So that one I shouldn't have to write the name, but it is cotangent. Okay? Just tangent with co in front of it. And again, it's the reciprocal of tangent. So if tangent's sine over cosine, cotangent is cosine over sine, or x over y, or adjacent over opposite. Okay? So we have our three original trig functions, and now we have their reciprocals. Okay? Not to be confused with their inverses. And that's one thing my students do all the time, is that they mistake inverses and reciprocals, especially in trig. Okay? They're not the same thing. A reciprocal means you switch your numerator and your denominator. Okay? Inverses means an inverse operation. And we'll talk about that in just a minute. Okay? Now, number one mistake my students make when doing this with trig is not studying these. These are things that you just have to know. These are basically formulas on a formula chart, and you just have to know it. There is no understanding here, okay? There is no, oh, I don't understand cosecant. There is no understanding. You just need to memorize the fact that cosecant is the reciprocal of sine. You just need to memorize that secant is the reciprocal of cosine. You need to memorize that cotangent is the reciprocal of tangent. Okay, so when my students say, I don't understand them, I look at them and I don't understand. Like, I literally tell them, it's not about understanding. It's about studying. You got to study them and you just got to know them. Okay, so that's the problem with trig, and that's what most students don't like, is the fact that you really have to actually study. There's no way of just knowing these. You've got to study to remember them. Okay? Now, the next thing, going back to the right triangle trig, when we are trying to find a side, so if we're dealing with a right triangle and we're looking for a specific side, we're using our regular functions, sine, cosine, or tangent. Okay? So if it'd be like using sine theta equals opposite over hypotenuse. Okay? So this I'm using when I'm trying to find a side length. Now, if I'm trying to find an angle, we're using the inverse functions. And that looks like this, where it's theta equals sine -1 of opposite over hypotenuse. Okay? There's a difference. This function here will find either O or we'll find H. But if I need to find theta here, if I'm missing theta, I use this equation. And it'll say theta equals, and then it's the inverse function, O over H. Now, I don't like using the inverse function. Normally, if you see me using them in my videos, I'll talk about arc sine. So it would look like this. Theta equals arc sine O over H. It means the same thing. Arc sine is the inverse, but it keeps me from thinking that this -1 here means the reciprocal, because that's tends to what people think, is that that is the -1 power on sine, but it's not. It really means arc sine. Okay, but in the calculator it looks like this, sine -1. Okay, that's it. That's the main issue with right triangle trig. Let's do an example. Okay, so real easy example. You first need to figure out which ratio to use. Okay, so what I've always told my kids, I used to teach geometry, is think of it this way. Shrink yourself down and stand where the angle is. Okay, so say I'm standing right here where the 55 degree is. I'll be able to touch two sides of that triangle. Okay, the two sides that I'm going to be able to touch are the adjacent and the hypotenuse. Okay, so in this case, this side is my hypotenuse. This is h, right? Which means this side is my adjacent and this side is my opposite. Okay, so I have my adjacent and I'm looking for my opposite. So which trig function has opposite and adjacent? Well, the only function that we have that has both opposite and adjacent is tangent. So I plug in my theta, I plug in my opposite, my adjacent, and now basically the easiest way of doing this is to cross multiply. So put this over 1 times x, 20 times tangent of 55. When you cross multiply, you get this, and then you plug it into the calculator, and you get your answer. Okay, that's all there is to right triangle trig. It's really, really simple. You just have to be able to figure out which two sides you have and dealing with, figure out the trig function that you're using, and then plug it into the calculator.